self-sufficiency and through the sustainable island society. So Kumejima this is the main Okinawa island. This is Kumejima, more small island, 100 kilometers. So seawater as a sustainable resources, so fresh water and some food and energy. So in Japan, already there are deep sea water site, 16 sites from the Hokkaido to the Okinawa. So Kumejima is the very largest intake facility, about 13,000 tons per day. So in Kumejima, already occurs a new industry using deep sea water, about 20 million US dollar project industry. So current deep sea water industry account for the 1/4 for the total economy. This industry very larger than sugarcane industry in Ireland, sugarcane. So, but recently more increasing. This is 2011. Recently more increasing. 25 million US dollar per industry, very increasing now. So, and this deep sea water industry mainly some project is a shrimp, clam, kuruma clam farming. So this price, summer is very expensive. Summer price is 30% higher than rest of the year. So in Kumejima, using deep sea water, so another island cannot farming this summer, but only Kumejima continuous farming, so using deep sea water. So this is expansion of demand of the deep sea water. So this is farmed kuruma shrimp and wild kuruma shrimp, but recently very increasing farm kuruma shrimp. So, and extended demanded deep sea water, sea grape. Sea grape is very tasty. In Okinawa, in summer cannot grow up. But if we use the deep sea water, so we can continuous grew up. So, and market demand and supplies, sea grape. Small, very high temperature is cannot, but this is controlled. This sea grape is a very good product. So, and recently, so Saga University constructed Kumejima satellite from the 2014. So this in the Kumejima satellite, we are now operating the small desalination project and hydrogen using OTEC electricity. So in Kumejima, now next step. So Kumejima is twice a deep sea water flow rate, so 1 megawatt, and after that is some business and demonstration project and technology development. This is now planning. So recently, new business utilization deep sea water, oyster, Japanese method of oyster purification with deep sea water. This is a new method, is no bacteria. So very tasty and very safety. So now this company, so using very large, huge deep sea water industry. So impediment to the implementation. So there are no technical hurdle to the implementing the Kumejima-model. And economical scale and existing technologies such as for the turbine make 1 megawatt OTEC easier than the small scale demonstration. So a pipeline to deliver capacity for the 1 megawatt class OTEC facility in the certificate investment, offset by the multiple use of the deep seawater and the surface seawater in the Kumejima-model. So now, Okinawa government post-OTEC seawater utilization project, so now started mini Kumejima-model. After use the discharge seawater, so using project. So just now we are started bridge the gap. NEDO project supported by Japanese government. Japan Marine United and Saga University started the double ranking cycle project. This is an installation of the new heat exchanger and turbine to increasing power output with the existing supplies. So, and some technology we are used. This is an evaporator as a NEDO project. So, as a NEDO project, we developed the high performance heat exchanger with the Kobe Steel Company. Kobe Steel Company is a treatment the surface, special surface. So this production method is not increasing the heat exchanger material, but heat transfer performance is 10% and 20% increasing. This meaning we can decrease our 10%, 20% total cost of the heat exchanger. This is a performance, overall heat transfer coefficient. If we use this new material of titanium, we can increasing over the 26%. This result depends on the condition. So we are trying to the double stage ranking cycle. So we expected the 10 or 20% increase of output. So already installed in Saga University. Now this project transferred to Kumejima. As you know, well, OTEC, this is a OTEC cost. This is about US cent per kilowatt hour. So large OTEC has a scale merit. Large OTEC is more economically. Small OTEC is not economically. This is the only OTEC. So 20 cent US cent about 10 megawatt, 10 cent 100 megawatt. But if you use the hybrid OTEC, deep seawater, so we can decrease the cost because we can share the deep intake tube cost. So now we are planning the 1 megawatt Kumejima-model, using some product, some industry, so we can decrease the total cost. So now we are installed about 100 kilowatt plant. This is very small OTEC, very, very small, but this is very important. So we can next step 1 megawatt, 10 megawatt floating, so finally 100 megawatt commercialized. We are now evaluating using this 100 kilowatt experimental data. So toward 1 megawatt for the sustainable island societies. So let's accelerate the blue revolution using OTEC for the blue earth together. Thank you. Thank you. Arigato. Danke.
Thank you very much for your introduction. And say it's still far from the lunch break, but we already all these delicacies. I think maybe this is a good place to go for one of the next OTEC symposia. But anyway, thank you very much for your clear presentation on this project. Other questions? Yes, there, please.
Can you explain a little bit more about the double ranking cycle?
So we need time. Later, I want to tell you. Yeah. I can lecture later. Yeah. The double ranking cycle, we can expected the more output because irreversible losses we can decrease. So already we are applied the ammonia water mixtures plant. So we are now 2 methods we are promoting: ammonia water mixtures project and double Rankine cycle project. So we are expected, depends on the site. Yeah, decrease in reverse loss is very important. In reverse loss, it means warm cellular temperature varied and working fluid temperature. This is loss is very important. So we have to decrease this is loss to increasing output. If need later, I submit the paper. I submit my paper to you.
Yes, there is another question. Can you bring the mic there?
I just have a question on the use of deep sea water for like oyster farming and prawn farming. Is there studies on the production cost compared to traditional farming when you use deep sea water? So a comparison between the costs from traditional method and using deep sea water and
Yeah, so in Okinawa, so traditional method cannot continue the plant in summer because very hot. But if we use the deep sea water, cool temperature, so plum and sea grape, we can continuous operation. Because plum and sea grape cannot grow up over the 25 degrees centigrade. Yeah, this is control. Deep sea water very cheap after install the intake tube, so we can decrease and we can safety operating.
Okay, thanks. Yes, please.
Professor Yasu, I always enjoy your presentation.
Thank you.
I have one question. For 1 megawatt size plant, you said the cost of electricity between 40 to 60 kilowatt hour per.
Yeah.
Okay. Does this cost include the cost of laying the pipes?
Yeah.
It
Of
does.
course.
It does.
Yeah.
Okay. Thank you.
Thank you.
Okay, all costs included. Yes, there. Okay, yeah, please here and then there at the back.
Kelly Kayoka from France Energy Marine. I'm wondering if you could say a little bit more about the government support that you receive, because you mentioned a development roadmap, 100 kilowatts, 1 megawatt, 10, 100. Does the government match its support at each step, or do you have to request support every time?
Yeah. Now, this is our sector roadmap. Not that this all supported by Japanese government. Now requested 1 megawatt. Next 10 megawatt is by private sector. But first 1 megawatt, if we realize 1 megawatt, so private sector won't buy self 10 megawatt. So until 1 megawatt supported by Japanese government. Now requested. Yeah.
Thank you.
Okay, and there is a question at the very back.
Yeah?
No, please use the microphone.
Yeah. Thanks. You showed that OTEC is feasible in Okinawa and southern Japan right now.
Yeah.
With global warming, is it expected that the warm currents will migrate northward and that OTEC can become feasible in northern Japan? With global warming,
The question is, when the Earth is heating due to the climate change, it will be warmer, and will OTEC also become feasible in the north of Japan?
Yeah, of course.
Yeah? No, with increasing temperatures on Earth due to climate change, will ocean thermal energy conversion become feasible in northern areas like the north of Japan?
Thank you.
No. We want to stop the global warming temperature by OTEC. Yeah, of course. Sorry. Mislead. Sorry. Not expected global warming temperature. Yeah.
Yeah.
We want to stop. We can stop, believe.
Yeah, okay, good.
Thank you.
This seems to me a very good ambition to install so much OTEC that we don't have any global warming at all. Okay, thank you very much for your presentation.
I still have a question.
I really enjoyed it.
I still have a question. May I still pose a question?
Can you say, yeah, there are probably so many questions. Maybe you can talk together further in the lunch break. Because there's already a following speaker ready, and that I'd like to invite Mr. Dr. Hyun-Yu Kim. Can you get to the stage? Before I